So today's lesson, lesson 7, is on bonding. So if you've ever heard of bonding before, this idea that things form covalent or ionic bonds, that's what we're talking about. So bonding, everything in the universe is made up of elements, and when elements come together to form compounds, they have to form bonds. One thing to note here, copper metal, if you think about that, it's Cu on the periodic table, but there's a bunch of copper atoms that come together to make up what we know as copper. Compounds are two or more elements bonded together. These we have mentioned before in class, but an example here would be water, which is H2O. Water is made up of two hydrogen atoms and an oxygen atom that's bonded together. This should be nothing new. You've been identifying these in class. Formulas are essentially the way that we write out compounds so we understand what we're talking about. Formulas, we use both letters and symbols, so we'll use letters and numbers. The numbers in form of subscripts are going to be really important. So the subscripts are going to tell us what elements are present and how many of each elements are present. So for example, water we know is composed of two hydrogens and one oxygen atom. Because we have H2O, that 2 tells us that there's two hydrogen atoms. The 1 is not written, it's just implied. If you think about it, if it wasn't 1, it wouldn't be written out there. So H2O, we know there's one oxygen atom. Another example would be carbon dioxide, so CO2. There's one carbon atom and two oxygen atoms present. Valence electrons are going to be discussed more later, but essentially they come from these electrons that are in the outermost shell. So if you think about, if you've heard of this idea of shells before and the nucleus, essentially there is kind of a drawing like this. This would be the nucleus, this shaded in part here. There are these shells that exist outside where there would be electrons present. So that's just a symbol for an electron there. We're talking about the outermost shell. That's going to be the one that you can utilize in reactions. What's most important is that we count valence electrons and we know how many valence electrons are in each element. So you're going to number these based off of the periodic table. So the periodic table kind of looks like this. It's not perfectly straight, but it essentially comes down here in the middle. And then the first column's over here, so we have 1, the second column's here. We're skipping all of these transition metals in here. These are much more complicated as we go across here. So then this starts out at number 3 over here, and it goes up to number 8. 8 is the number of valence electrons in the noble gases. So for example, hydrogen, which is the first one up over here, where it's written, has 1 valence electron. Magnesium's in the second column here, so it would have 2. The third column is where aluminum lies, and the fourth column is where carbon lies, and so forth. The octet rule is going to be essential that we remember. So elements of the periodic table are essentially satisfied, in quotes, when they have a full outermost energy level, and we're going to focus on the level that is full when it contains 8 valence electrons. So the octet rule, if you think about octagons or something else, you know that starts with that oct prefix. That means 8. So we're shooting for 8 valence electrons. So some of them already have 8 valence electrons. Those are the noble gases, the furthest right, helium, neon, argon, krypton, xenon, and radon. But the other ones are going to have to form ions to get to these 8 valence electrons. So they can either form cations or anions. For cations, to meet the octet rule, elements with less than 4 valence electrons will lose electrons and have 8 in the outermost energy level, resulting in a positive charge because they have less electrons than they originally did. So for example, sodium is going to form a +1 cation because it had 1 valence electron originally, so it lost 1 to meet the octet rule. So if you think about something that has 1 valence electron, it's going to be a lot easier for it to lose 1 than to gain 7 to make 8, which is why it's going to form cations. One way to remember cations is when it comes to cations, if you think about an actual cat, they're always positive, so they have pause, so there's a positive charge. The other option is to form anions. Anions, to reach the octet rule, elements that have close to 8 valence electrons will gain electrons to have 8 in this outermost energy level, resulting in a negative charge because they have more electrons than they originally did. So as they pick up extra electrons there, they're going to gain a negative charge. So for example, oxygen is going to have a -2 charge because it's only 2 away from having 8 since it had 6 originally. So it's going to pick 2 up and gain 8 valence electrons to satisfy the octet rule. So again, you have to be able to recognize that the column numbers is going to be equal to the number of valence electrons. So the first column, something with hydrogen, is going to be +1. Second column, something with beryllium and so forth, going to be +2, so on and so forth. So being able to recognize these is key. Carbon right here could be plus or minus 4. If you think about 4 is right in the middle of reaching 8, so it's just as easy for it to lose 4 or to gain 4. It could do either one. Helium here is not going to have a charge because it already is satisfied. It has 8 for the octet rule, so it's not going to have a charge. It's not going to form ions. So for example here, we're going to try to identify the charge on the following elements. Calcium, we would look up at the periodic table, see it's in the second column. Since it's in the second column, it's going to have a +2 charge. Fluorine is in the 7th column when we number them that way. It's only 1 away from having 8. It's going to form a negative ion. It's going to be an anion. It's going to be -1. It's only 1 away from having it. Bromine, same thing as fluorine, -1. Nitrogen's 3 away from having 8. It has 5, so it's going to form a -3 anion. Strontium. Strontium is in the second column. It's down beneath magnesium, 2 below. There's calcium and strontium, so it's going to have the same thing as calcium, so +2. Aluminum is in the third column when you number them, and it's right underneath boron, so it's going to have a +3 charge. Magnesium is in the second column. It's right below beryllium, above calcium, so it's going to have the same thing as calcium, so +2. There's a second aluminum, and don't worry about this one. This one's just the second one. Phosphorus. Phosphorus is right below nitrogen. Nitrogen has a -3 charge, so does phosphorus. Lithium's in the first column, so it's going to be +1. When it comes to transition metals, these are some exceptions. So they could have many charges. So transition metals are going to vary. So they could have more than one. They could also have differing charges depending on the compounds it forms. That situation is true for these elements under the diagonal line, or the steps. They're essentially going to have more than one possibility, so they would act like the transition metals and have more than one. It's not that simple. It's the same thing for the lanthanides and the actinides. They're the part of the periodic table that's listed below the periodic table, the 2 long rows there. They belong in that transition metals, so for that reason they're going to have the same thing going on as these transition metals and the elements below the line or the steps. Essentially it's going to vary. The noble gases are the ones that already have 8 valence electrons, so they're not going to form ions, they're not going to form a charge. Things in the carbon column, they're halfway between 0 and 8, so it's just as easy for them to lose or to gain electrons, so they could be + or -4. Boron has a couple of exceptions, but generally it's going to act as a +3. It's just going to follow the rules in the third column. And that's it for these exceptions. Down here to naming cations, so notice that they're named with the word ion or cation after. You'll see it either way. You can write this as +2 or 2+ for the charge. You can do either one. That's fine. The difference down here for anions, anions are going to be named by deleting the ending of the nonmetal and the metal, or the nonmetal, and adding "ide." So you'll see down here it's chloride, not chlorine, sulfide, not sulfur, and so forth. That's all you need to know from today's lesson.